Warning, this video contains strong language and one image that all viewers should find offensive. Viewer discretion is advised.
You claim that I have got it wrong when I say that we measure the distance in time to get the value so that we can work out the distance to the star.
Ho ho ho, you beautiful bastards. I'm jolly old Saint Prick, aka the Triggered Limey, and welcome to another episode of Wanker Wednesday. Before we get started, I would like to give a special thank you to Little Miss Now, who with her father Nowpinion made a wonderful video about ocean pollution and its effect on the wildlife. Excellent job, young lady. Keep up the great work. If you haven't checked out Nowpinion and Little Miss Now, you're missing out. Go check them out at some point by either clicking here or following the link in the description. Definitely worth a watch. Now to business. As you can probably tell, today we're taking a look at Anthony Sleepy TikTok Predator Riley. It's not really surprising, but Leaky is just another flurf that thinks that sextants somehow destroy the globe.
Okay, this is a short video dedicated to Roohif. Roohif is a smarmy, patronising, condescending prick on the anti-flat earth side. He doesn't realise that he doesn't know everything about everything, but I do realise that I don't know everything about everything. So this is a request for further information from Roohif, because he seems to be the font of all knowledge when it comes to anything to do with anything in this topic. Self-proclaimed, I might add.
Says the twat who thinks he understands the scientific method better than any actual scientist and thinks that he disproved Newton and Einstein.
Obviously, the current buzzword at the moment is sextants. This year is all about sextants, and we've been talking about it for a while. Sextants do not work on a globe for a variety of reasons, all of which are completely ignored by the anti-flat earth cult members. And today we're going to go through why this is an issue for the ball earth believers or the anti-flat earthers. 5 slides, I'll be as quick as I can, and we'll end up with a question for Roohif. I expect a video response, Roohif, because I want to see you commit to something stupid. Slide 1. Everybody thinks that when we measure out to the horizon at a star, everybody thinks that we're going to measure like this. We're going to measure the angle to the horizon up to the star, get a value, and then you're going to go, great, we've got a value. But a legitimate question is, how do you get the GP distance? The distance from the observer on the right. There's Roohif stood on the ball. Notice I've got the ball underneath him. How do you get the observer, how do you get the distance out to the horizon? Because that's the issue, isn't it? And that's a legitimate question. I asked that the first time I saw this issue coming up. I asked myself the same question. I knew eventually somebody would ask it, so I just bit my tongue and I waited to see what would happen.
Just admit it, Riley. You had no idea how to answer that question because, just like usual, you have no idea what you're talking about.
And eventually we're now at this point. And the issue is, when it comes to this first slide, is whatever you point whatever you set your baseline to, if we say you set it to your horizon, because that is what you do. But they say, well, you don't need the horizon, we set it to horizontal.
When do any of us actually say that? Unless you're talking about the bubble sextant, which we would tend not to use at sea because it's kind of hard to keep it level as the boat is rocking back and forth. You'd more use a bubble sextant, you could use it on land or in aircraft. Or are you getting confused with horizontal sextant angles, you Pratt? Your illustration even shows that we're talking about vertical sextant angles for which we do use the horizon. So either you're just wrong or you do know the truth and you're just being a slippery little.
So they ignore the horizon and they set it to that. Well, if you ignore the horizon, then you haven't got accuracy with your measurements. Now, ultimately, they always say how important it is for accuracy. But I suppose you could say to them, well, I can understand that you don't necessarily need it. So at this point, you could set yourself without having a straight line to the horizon. You could set it to no horizon at all, based purely on horizontal.
First off, you pillock, 7/6R is an approximation for refraction pretty close to the horizon. Obviously, refraction can vary depending on weather, temperature, and even the location of the celestial body that we're looking at. Even if the Earth was flat, because of pressure gradients and temperature and everything, you'd still have to account for refraction. And yes, we sometimes say that the light is curving or bending due to refraction. I personally prefer to say bending, but basically, as the light travels from any transparent medium to another, it is going to deflect ever so slightly. This video by Babek Tafreshi perfectly demonstrates how refraction can affect star trails. So as you can see here, because of the light refracting through the different mediums, it looks like they're just going all over the place as they get closer and closer to the horizon. And here we can see how it affects the sun as well. So let's doesn't really help your argument, does it, you know? Because to be fair as well, if the sun was local and we were just losing sight of it because of perspective or how far it's traveled, we wouldn't see that heavier refraction.
Now, obviously, remember that there is no line of sight to the horizontal on their model that's straight because of 7.6R. The line out to the horizon or the set horizontal on their model, because you're looking through the optics of the sextant, is subject to refraction at the rate of 7 over 6R and is therefore a curved line. So their argument immediately fails.
It really doesn't.
Everything on their model is a curve. It's applying curvilinear geometry, right? It's not applying Euclidean. There are no straight lines on their model.
Why can't any of these bellends seem to wrap their tiny little minds around tangents?
So they can't even do this when they try and set to the horizontal, because their horizontal isn't a straight line in their model.
Sake, you'd stepped away from flat earth for a while, Limey. You know that all of their arguments come from a total lack of understanding, yet you come back for more. You sick bastard.
Well, that debunks their model, doesn't it?
No, it just shows that you wankers don't have a Scooby-Doo.
Because they can't use a sextant for it. But anyway, we'll come back to that. But it is a legitimate question to ask. How do you get the horizontal distance? And that is legitimate.
We can actually do this very easily. We want our vertical sextant angle, so we measure from the horizon to the celestial object, subtract that number from 90, and then times that number by 60. This will give us the distance in nautical miles.
We've been doing a bit of research into how celestial navigation is done using a sextant, and this is what they do. So if we look on slide 2, to get around the issue of the horizon and the ambiguity that surrounds it on both models, what they do is if you're on a ball, like so, I know this is begging the question, but I've got to do it for their argument to show how it doesn't work for them. But it only works for us. But we've got Roohif here. He's on the right hand side. He's on his ball and he's setting his zenith. He's got a plumb bob or a pendulum or whatever to set his vertical. Now, obviously, on their model, everybody's got a different vertical. But for this example, it doesn't matter because this works for everybody on a ball to a point.
And yet it still doesn't work on a flat earth, you muppet.
So at this point, Roohif sets his vertical. And then you can see at this point that the line it's got an infinite distance. So the vertical is as far as you can imagine in the biggest number that you can ever imagine. It's not set to any particular distance. It's got a direction, but it's got no magnitude. There's no quantification there. It's an indefinite line.
You really don't realise that we don't do it that way, do you, Riley?
Let's move to slide 2.
I'm pretty sure we're already on slide 2, which means you're actually about to move over to slide 3, which means you can't even get this right, mate.
What you then do is you want to measure the distance of the dotted line in time.
You what?
So to measure that distance, because once you get a distance, right, because we all know we need an angle and 2 sides, or we need 2 angles and 1 side. Well, we need, in this instance, we're going to be using 2 angles and 1 side. So what we're going to do is we're going to measure the distance of the dotted line in time. So I don't mean time as in hours, minutes and seconds. I mean time as in arc seconds, arc minutes.
Which aren't measurements of time at all. For sake, you really don't understand any of this, do you?
Time in this instance is applying the inverse trigonometric functions, and you can see by this clip that these are used to obtain an angle from any of the angle's trigonometric ratios. Inverse trigonometric functions are widely used in engineering, navigation, physics and geometry. So this is essentially what's being applied at this point.
No, it isn't, but please do continue to show yourself up. This is priceless.
So we are measuring the distance of the dotted line as a length in time, not in meters or kilometers, miles, kilometers, anything like that. This is measured in time, so it's arc seconds, arc minutes, right?
Leaky, you absolute moron. 1 arc minute is equal to 1/60th of 1 degree. For latitude, this is 1 nautical mile. For longitude, this can vary because Earth is oblate. Around the equator, it is 1.151 nautical miles. Oh, and 1 arc second, funnily enough, is 1/60th of an arc minute.
Once you get that distance, you've got an angle from the observer. You've now got a distance from the observer, which is the dotted line. But at this point, it's the only two values that you've got. You need a third, don't you? But the moment you get your distance in time, the dotted line, once you measure that distance in time, you then crop off the values, the infinite lines that we had before. The infinite lines are no longer infinite.
Which is kind of pointless, but go on.
Once you get your distance in the dotted line, you then get a 90-degree angle from your zenith, your vertex of your zenith, your highest point of your zenith. you get a 90-degree angle from there. So at this point, we now have your angle from the observer, you have the distance measured in time, number 2.
And you still haven't explained exactly how you get that value for number 2, that distance.
And you have your 90-degree angle, number 3. But you'll notice now that the lines are no longer infinite. The lines are now cropped because we now create a triangle, a celestial triangle, in the sky, not against the ground. And this is irrelevant to the shape of the Earth.
Now, even though you lot always this up and say that we can't have a triangle on a curved surface because it needs a flat bottom or whatever to sit on, you're completely fine with a triangle having one point close to Earth at eye level though. So, you know, again, nothing's ever touched it. Even on a flat Earth, it wouldn't touch Earth, would it?
So at this point, kind of, ball earthers can get away with arguing that the sextants work on a globe.
Me, I really do think that a part of Riley knows that he's full of shit.
But let there be no doubt, we do have the 3 values that we need. We've got the number 1, the measurement of the angle from the observer. Number 2, the distance in time of the star to the zenith. And we've got number 3, we've got the right angle 90-degree. And at that point, the trigonometry can be done.
Except that we don't really need to use trigonometry here, as I've already shown.
However, because on the sphere, on their model, this can't be done because of 7/6r. When the observer looks out to the star, whatever angle that is, that line, that optical line of sight through the sextants, imagine that you're looking down the barrel of the gun, you've got the sextant up to your eye, and you're looking out to that star. On their model, because light does not follow a straight line, that means that this line from the observer to the star is a curve because of 7/6r.
Yet we can see evidence of refraction every day. In fact, our eyes even refract light as it enters them. So if the Earth was flat, you'd still be dealing with light bending. And this is why we make corrections for refraction. That way we can keep everything else simple.
They cannot triangulate with a curve.
1, yes we can. 2, this isn't triangulation. You idiots seem to just think that because sometimes we make a triangle, that makes it triangulation. No, it doesn't. That's not how it works. And again, we can work out our distance from the GP with 1 angle. No triangle needed.
They need 3 straight lines and they need angles.
As I explained already, we just need to subtract our vertical sextant angle from 90 and then times that by 60. Then we can use the nautical almanac to establish the GP of the celestial object we're looking at, and then we can measure the distance that we just got from our calculation, use that as a radius. We've got our circle of equal altitude or circle of positioning.
Well, that means that angle 1 cannot be achieved on their model because the line, the hypotenuse, is subject to a curve, 7/6r. So that angle cannot be measured from their perspective.
Feels like I'm repeating myself again, but yes we can. And I'll also repeat, your model, and I use that term extremely loosely and with utter disdain, has refraction as well. This isn't really going well for you, is it, you TikTok child pretending
The zenith is a straight line because that's the only time where there's a straight line on their model. The zenith, the vertical from the observer. So the zenith is a straight line, but the hypotenuse, the angle, the line out to the star, is a curve because everything's apparent in their according to their model. So they cannot do this.
Your horizon would be apparent too. You say that things disappear from the bottom up because of perspective or diffraction or whatever big words you learned that week. Well, this means that you can't pinpoint your horizon exactly either, can you? And it's only you flirfs that say that we can't have anything but an apparent horizon. That you tussputts do come out with some bollocks, don't you? Hi, Editing Limey here. I kind of missed a trick when I was doing this current bit. He was talking about obviously apparent stars, and I went straight with horizon because they're always saying that can't have a geometric horizon, only can have an apparent one. So yeah, like I just said, obviously their horizon is technically apparent as well because of refraction, even when it's just a little bit, and obviously their stars would be as well. So I missed saying the stars, but yes, their stars would be apparent as well because of refraction.
Now, Roohif, you claim that I have got it wrong when I say that we measure the distance in time to get the value so that we can work out the distance to the star on Earth when we're the GP, the distance to the star along the horizon on Earth. Okay, explain how I've got it wrong, please.
See, this, just like everything else that you misrepresent, Anthony, just shows that you never take the actual time to learn anything. You just skim through, cherry pick a few bits that you think fit what you're talking about, and then assume that you know how the it works.
With diagrams and showing how you can do it on a ball, because you guys can't do it on a ball. Everything's a curved line in your model apart from your vertical. So curvilinear, you can't have it both ways.
Again, this is why we make corrections.
If you're going to apply curvilinear geometry, fine. Sextants don't work on a sphere.
They only work on a sphere. And you keep bringing up curvilinear geometry. We don't use that in celestial navigation. We use basic Euclidean and occasionally a bit of spherical.
If you're going to apply Euclidean geometry, then that's fine as well, but you've got to accept that your 7/6R's out the window.
He still doesn't get it.
Can't have it both ways, gentlemen. So it's either Euclidean or curvilinear.
It really isn't, because refraction is a thing.
If it's Euclidean, you can't have 7/6R. If it's curvilinear, then you can't have sextants on a globe, but you can't have both positions at the same time. You're in a direct contradiction. This completely debunks your model, because no matter which way you go from here, your model's over, guys. You're in a direct geometrical contradiction. You cannot get out of this.
What a bell end. Okay, to any flirfs watching, and this is the blatant truth, sextants do not work on a flat earth. As you can see, either your distance per degree keeps changing so it doesn't work, or we can measure by degrees from the ground and see that they point in all random directions.
Look forward to your hate video, Roohif. Make sure you put in a couple of insults about how I can't triangle.
Which he definitely did. If you want to check out Roohif's fantastic video response to Riley, click here. So before we go, I would like to pose a question to all flat earthers. If a sextant can only work on a flat earth, and so many of you claim to understand how it works, how come not a single one of you delusional has tested and shown it in the real world? I really can't wait to see if any of you spanners come up with anything. Please remember that you can help support the channel through Patreon, PayPal, or even by buying my merchandise. Links are in the description. But if not, a like and a share is just as fantastic. If you haven't seen this video that I did on Riley, consider watching it now. I hope that you all have a very happy Christmas, Kwanzaa, Hanukkah, or whatever you're getting up to this holiday season. I've been the Triggered Limey, and I'm out.